Hi, in this video we are going to talk about the solution to lead code 104. The problem is given a binary tree, find its maximum depth. Imagine that I have a binary tree like this one and I want to find the maximum depth of that. So the maximum depth is what we are looking for is the number of nodes that exist between the root to the leaf. Which one is the maximum? For example, for this one, if I go to the left, it's only one node here, plus one is 2. For the right, I can go to 6 and to 7, so it's gonna 1, 2, 3, and I can go to 2, 6, 4, 5 or 2, 6, 4, 3, which would be 4 nodes. So the maximum depth of this binary tree is 4. So for doing that, so we need to go to left and right as we saw. So, and whenever I want to do that, I need to go for all of the nodes. What would be on the left, what would be on the right. But for the leaf nodes, I know there is no node on the left or on the right, so I can return 0. That is important in the code, so whenever we get to the leaf, we have to return 0. The other thing is that, considering, for example, the leaf 1, so if I want to return the value to the left side of the root, so I could say, okay, on the left side, I don't have anything, it's 0. On the right side, it's 0. But I have one node here, so I have to add that and return it to 2. Similar for 3, I return 1. For 5, I return 1. For 7, I return 1. But look at the number 4. I have on the left side 1, I have on the right side number 1, but I have also 1 here. So I should return 2 to the left side of 6 here. Now let's look at the left is 2, on the right side is 1. So what should I return here? We should return the maximum. So maximum of 2 or 1, because that is where we can see the maximum depth. So we are going to return the maximum between 2 and 1, and we have a 1 node here, so we should return 3. Now I'm on the root. So on the root, on the right side, I had 3. On the left side, I have 1. So I should return the maximum. And we have 1 node, which is the root. So that should be 4. So if you go back from 4, we can see we are following a formula, which is the maximum of the left and right plus 1. Maximum of left and right and plus 1, which is the node. So for 2, for 6, and for 2, and for the root. So we can come up with this formula then. Now let's go over the code. I have the similar tree here, just exact same tree as we showed, and I have a class of the node which has a left, right value, and I have defined a tree, which is this tree, and I want to find the maximum depth of that. So as we said, whenever we are getting to the root leaf, so wherever root is none, so return 0. And we are going to go to the left and go to the right and input them to our function maximum depth again to find the left and right values, and then the value that we return is the maximum of left and right plus 1. And now let's run the problem, and you can see we have left, right, left, right, left, right, and we can see the maximum depth of the tree. So if you want to go over that again, so we gave the root as the input to our solution. So that was the root, but it's a recursion solution. So it starts from the leaf, node 1, so 0, 0. Then go to 5, 0, 0. Go to 3, 0, 0. Go to 4, 1, 1. Go to 7, 0, 0. Go to 6, 2, 1. Go to 2, 1, 3. And the maximum depth of the tree is 4. So in this way, we can find what would be the number of nodes in the maximum depth from the root to the leaf. Now let's look at the time and the space complexity. So for the time, we are going to visit each node exactly once. Therefore, our complexity is order of n. For a space complexity, it depends on your tree. If it's extremely unbalanced, so that go to order of n. But if it is completely balanced, so that would be log of n. So the number would be between greater than log of n and less than n. So that would be the solution to the lead code problem 104. Thank you so much.